Alright, so we made it to the last example. So we've talked about already how to create a function or transformation equation from the transformation from a graph. We've talked about how to create a function from the actual transformations given to you and the parent function given to you. But now they give you a function that's already transformed. They already have transformations in it happening already. But then they also give you more transformations to come up with a brand new equation. So with that, that's what we need to make sure we do and figure out. How do we find the new equation by using the transformations they give us? All right, so looking at it, if you want to, well, not if you want to, we're going to. So if we were to look at this function here, we know for this graph, we'll go for 1, 2, 3, 1, 2, 3, 4. Let's say 5, 6, 1, 2, 3, 1, 2, 3. That's fine. All right, that should be good. And 2, -2, -2, -4, -6 there. That looks raggedy. Sorry, guys. All right, so we go ahead and originally graph the original function that we have right here. So we look at that one. So we know we're going to move up 5. We know this goes up 5 originally. We know this goes to the right 3. Sorry, left 3. Sorry, left 3. Opposite what you think. Left 3. All right, so we're going to go up 5. Woo, I didn't put all those up here. So we'll say this is 4, this is 5 right here. So we go up 5, and then we go over to the left 3. So over here. Then it's a cubic function, so it goes up like this and down like this. All right, so we have that original function. But then it says we're going to move it left 2, and then we're going to move it down 3. So it's already gone to the left 3, so we move it over 2 more places to the left. So here we go, we're at 3, and we go over 4, 5. And then we go down 3, so it goes down 1, 2, 3 right here. So this is the new graph, but we have to figure out what the new equation would be. So you can kind of read the graph and kind of tell like what the new equation would be. And I'll do that part too. So if we look at the new graph, that goes over 1, 2, 3, 4, 5 to the left, and then goes up 1, 2. So technically here, the new equation would look like this, just by looking at the graph. Cubed, and then plus 2. Now, with that, that's being able to see it graphically and go from there. And when it comes to this part, especially if you're planning on going to calculus there, it's important to know how to figure out things graphically and analytically and algebraically, pretty much the same thing as analytically, but algebraically also, and graphically and all that good stuff. So you know how to do it multiple ways. So here, the other way of doing it, we're going to do it algebraically. So we just did it graphically. Let's go algebraic. And it will give us the exact same answer. And I'm going to give you, I give you 2 different ways of looking at it, and you figure out which one's the best that works for you. Whichever one works best for you. All right, so we know here for the left, we have the equation right here. This equation right here. And they give us the moves. So if we move left, that means that we're going to do opposite of what we think. That'll be plus 2. If we move down, that's minus 5. So minus 3. And we know this is going to be our B, and it's going to be C. And again, remember B goes opposite of what you think. So if it's left, that means you do plus 5, plus 2, plus. If it moves left, it means you do positive. If you move right, it moves that is negative. So here, what I'm going to do is algebraically, I'm just going to take what we just said right here, and I'm going to move it in. So this is our B right here. So I'm going to do a plus 2. That's our C. So I'm going to do C here. Put minus 3. And I'm going to just simplify it down. Work this out. We have x plus 5 cubed plus 2. Which is exactly the same thing we got right there. So you can do it algebraically or you can do it graphically. To me, I think algebraically is simpler, but you can do either way, and you will still get the same answer. Oops. Sorry, I did wrong. There should be a plus sign right there. My bad. Because remember, going to the left, that means you go opposite of what you think. So it shouldn't be a subtraction, it should be a positive. My bad. So addition sign, addition sign. Remember, opposite of what you think for a B. So see, guys, I mess up on that at times too. So you might mess up on it. If you do, it's okay. But just keep working on it to make sure you get it. And so that was like the first time I literally messed up on a problem. Sorry about that. My bad. My bad. All right. So with this part, next part, I'm going to do it again graphically, and I'm going to do it algebraically. So graphically, we know we're dealing with a linear function. So that means it's a diagonal line from left to right, going up from left to right. So we know we have our transformations. We know we're going to move right 4, move right 4, and we're going to move down 6. Remember, again, opposite of what you think, and then it's going to shrink or compress. So we're going to go over 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So I'm going to do 2, 4, -2, -4, -6, -2, -4, and then 2, 4. All right, so move over 4 and come down 6. So we're here. And then it shrinks, which means it comes closer to the x-axis. So instead of it being this way, instead of it being that way, we're going to go ahead and do it a little more, less inclined. Make it closer, in other words, closer to the x-axis. So we have that. So with that, we're going to move it to the right 3, and then we're going to move it up 4. So move it to the right 3, so go like some more this way. So 1, 2, 3. That's kind of big, but it's okay. So that was 5, 6, 7. So if you move it over 3, so it goes over 1, 2, 3. And then it says remove it up 4. So that's at -6, 1, 2, 3, 4. So now we're at that spot. All right, and then we just draw it up. So as long as it's supposed to be the same slope. So with that, hopefully you should be able to write out the equation. So y equals, keep that 3 there, because it's still slanted and still has that slope there. And then we went over 1, 2, 3, 4, 5, 6, 7. So x minus 7. Come on, write it. Come on. Put it below it. So we have y equals 3, x minus 7. And then it went down 2. So minus 2. So we went over here 7. And then we went down 2. And remember, it goes opposite of what you think. So we went this way 7, which means -7. And then we go down 2. Okay? So that's algebraically, graphically, sorry. And so algebraically, let's go through that too, just to make sure. Huh? Stop being difficult, board. Stop being difficult. All right, so we have that graphically. And then here, when it comes to algebraically, like we just did, we go ahead and say, okay, it goes to the right 3. So that means it's going to be subtracting 3 here. And we're going to go up 4. So it means we're going to do plus 4. All right, so algebraically again, we move here. And so we get y equals 3, x minus 7 minus 2. And again, it's the exact same thing we got right there. So algebraically you can do it, or you can do it graphically, or you can do them both. It's up to you. But it will give you the exact same answer each time. So here. is what I was looking for the second one. This is what I was looking for the first. Bam. And so that's it. That's all we're doing with transformations.